1.5, graphs of sine and cosine functions. So we're going to start with basic sine function, or the parent function, which is y equals sine of x. And we're going to graph this in one period first, from 0 to 2 pi. So we can divide the period into 2. This is pi over 2, and 3 pi over 2. We know the range of the sine is from -1 to 1. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is the same as sine of 0, so which is 0. So these are the values we already know from the table and the unit circle. So we connect, and this is the sine graph in one period from 0 to 2 pi. So we can continue this because actually the sine continues. And we're going to write down that the period of this function is 2 pi. In other words, it repeats every 2 pi. The shortest pattern is 2 pi. We're also going to write down the domain is all real numbers because it goes on and on. The range, however, is limited from -1 to 1. Now the basic cosine function, or the parent function for all cosine functions, y equals cosine of x. We're going to graph again in one period first, from 0 to 2 pi. Divide this in half, that's pi over 2, and 3 pi over 2. And we know that the range is still from -1 to 1. Now we know cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is the same as cosine of 0, which is 1. So we connect these points with a nice curve. So there are no sharp corners, and it looks like an open ball. And continue. And we're going to write down again here that the period is again 2 pi. This is the smallest length of a pattern repeating. The domain is all real numbers, and the range is the same, -1 to 1. Now we're going to learn how to graph functions, sine and cosine functions, that are transformation of those two. So example 1, we're going to sketch the graph of y equals 2 sine of x in the interval from -pi to 4 pi. So before we proceed with the graphing, let's write the formula for a general sine function. So that would be y equals a, which we call amplitude, sine of bx minus c plus d. And we're going to explain those letters are actually numbers. A is the amplitude, and actually the amplitude is the absolute value of A. So the halfway distance, which is the halfway distance between the max and the minimum value of the function. So if you look at the basic sine or basic cosine, the max value was 1, the minimum is -1. So the total distance is 2, halfway is 1. So the amplitude in our parent function, I can write this here, the amplitude is 1. And the same with the sine. Amplitude is 1, which is the halfway distance from the highest to the lowest point. So D, we can say that D is the vertical shift and the period is being affected by b, which is also a number. So the period for the sine and cosine, so we wrote this for sine, but also we can write the same formula for cosine. It's very similar. This is c here. And the vertical shift for both sine and cosine, the period for both of them is determined by the formula 2 pi over b. And then c will be the phase shift. We'll talk about it. Maybe we should write this down. So let's write down phase shift or horizontal shift. That is a number, c over b, or how many units you shift the graph to the left or to the right. So the left and the right endpoints of one cycle, let's write this down, the left and right endpoints of one cycle interval can be determined by solving these two equations, bx minus c equals 0 and bx minus c equals 2 pi. So let's go back to our parent function, and we did one period. So here is the left endpoint of one cycle. Here's the right endpoint. The same with the cosine. Here's the left endpoint. It's 0, 1. Here's the right endpoint. So that's one period of the cosine, one period for the sine. So if we have a transformation, those points are not going to be the same, and we're going to determine the new cycle and the new left and right endpoint by solving these two equations. So that's for one cycle. Or we can use the phase shift, either one. So we have all the formulas needed. Let's go back to our example 1. And there is only one transformation here. Y equals 2 sine of x in the interval from negative pi to 4 pi. We want to sketch this. So we're going to start with A. The amplitude is 2, and that's the only difference between this graph and the parent function. Nothing else, no phase shift, no vertical shift, no, the period is the same. So the period, let's write down also that B, that's the number in front of X. Let's look at our formula. So B is right here. The number in front of X, in this case, is 1. And C is 0, which means there's no horizontal shift, and D is 0, which means there's no vertical shift. So only the amplitude is the difference. So now when we sketch this graph, and it's a sine, so we remember what the sine looks like. It starts at 0. Let's do one period, because that doesn't change. It's still 2 pi, period. If there is no phase shift, then the period's the same. So period is 2 pi. And we're going to split this in half. This is pi, pi over 2, and 3 pi over 2. And it's a sine. The sine starts at 0, but instead of going to 1, the maximum point will be 2. So let's see what was 1 like. This was 1. So this is going to be 2 now. And the lowest point will be negative 2. So here's our one period. It starts at 0. And it goes all the way to 2, so it's kind of stretched vertically, comes down here all the way down to negative 2 and ends in 2 pi. So connect this with a nice curve, and you see it's the same graph except it's stretched vertically. Now, it says to graph it from negative pi to 4 pi. So we need to continue it. So this is 2 pi, then this is 4 pi. And we want, on the other side, negative pi. So now we want to split this interval here and this one. So let's continue the graph. It's going to go up to this point, come down here, all the way down here, and end at 4 pi. Oops. So you want, let's see here, let's go back and go exactly through this point and end here. And we need to do one more. Here you go. So this is the graph. All right, another example where we sketch this time y equals 1/2 cosine x. So the only difference is here that a is 1/2. So it's going to be shorter than our parent function. Everything else is the same. So the period remains 2 pi, no vertical, no horizontal shift. So let's sketch this. We have, and it doesn't say an interval, so if it doesn't say, you sketch one period and then you continue it. So I always break my 0 to 2 pi interval like this. So if this was 1 and -1, your amplitude is 1/2. So this is 1/2, and the cosine starts from the bottom, goes down here, all the way down. That's -1/2. Come back to the x-axis and here. So connect this with a nice curve and then continue it. So this is our new graph. Now, let's see what happens if we change the period. So how do we know the period has changed? Well, if b is a number not 1, for example, in this case, a is 1, the amplitude is 1, but b is 1/2. b is the number in front of x. So b equal 1/2. Recall the formula we wrote about the period right here. It's very important. This is the formula for the sine and cosine u period. So 2 pi over b, period, 2 pi over b, and b is 1/2. So 2 pi over 1/2, which is 4 pi. So now our period is a lot bigger, twice as big. Everything else is the same. So we're gonna sketch, this is 2 pi and this is 4 pi. So now when I'm breaking this down, this is gonna be pi and this is gonna be 3 pi. The amplitude is 1. So the graph is from -1 to 1. And we're graphing sine. So remember, the sine starts at the origin, goes up, and then down, back here, all the way down, and back here where it started. So we're connecting with a nice curve. It's kind of stretch horizontally. And continue. So this is our graph. Y equals sine x over 2. Okay, now we're going to see an example with the phase shift. So example where we have to sketch y equals 1/2 sine x minus pi over 3. So let's write down what is a. The amplitude is 1/2. B is the number in front of x is 1, which means the period has not changed. So the period is 2 pi again. Period is 2 pi. But what we have is c. C is pi over 3, so that's the phase shift, and d is 0, of course. So let's use the formula that we wrote down about the left end and the right end points. So by solving these two equations, bx minus c equals 0 and 2 pi, we're going to find the left and the right end points of one cycle. Whether we're doing sine or cosine, it's the same. So we're going to solve x minus pi over 3 equals 0, and x minus pi over 3, that's what the argument is for sine, or the input, equals to 2 pi. Or you can think about c equals pi over 3, that means we're going to shift to the right pi over 3. But I think this is easier to find the points. So pi over 3 is the starting point of one cycle, of a cycle. And solving the other equation, plus pi over 3, x equals 2 pi plus pi over 3 is 7 pi over 3. And this is the ending point of one cycle. And that's what we're going to do. One cycle, and then we're going to continue it. So we start to graph, and we're graphing a cosine. So remember what the parent function of the cosine looks like. Here it is, the blue one starts from the top. It's like an open ball. So we are going to start with the amplitude, and the amplitude is 1/2. So if this is 1 here and -1, then here's 1/2. So this is 1/2, and this is -1/2. So this is our amplitude. But now we're going to determine where the starting point is. That's at pi/3. Now let's write down our interval here, and the period is 2 pi. Okay, and we can break this down. This is pi/2, and 3 pi/2. But our graph is going to shift. So the beginning point is pi/3. That's less than pi/2. So this is our first point right here. Then, so everything is shifted pi/3 basically. Then the point is going to be over here when it touches. All the way down would be here, then back here, and we're ending a little bit to the right of 2 pi. So this is 1 period of our function. Okay, oh, we're doing sine. It is sine. So I did cosine. So let me go ahead and change it since I already graphed the cosine. So let's make that a cosine since I graphed the cosine. All right, let's continue because it doesn't say in what interval to graph it, so we're just going to continue a little bit. So here's the ending point. The ending point is at 7 pi/3, which is right here. And the beginning point is at pi/3, and that's what we found. So basically our graph, our parent graph, is shifted pi/3 to the right. And that concludes the lecture for 1.5.